Hello, today's Blender tutorial is about rigging the controls on an aircraft. And I want to have two caveats before I start the tutorial. First of all, I'm not an animator, and I'm sure that animators out there will have much better ideas on how to rig stuff. I pretty much do still images. So the goal of my rigging is just so that I can position things like the control surfaces and the propellers and the doors and stuff in a convincing and appropriate manner. If you're doing animation, there's probably better ways to do it. The other thing is this is not going to be mechanically correct rigging. I'm not finding the exact hinge lines. I'm not animating any of the hydraulics or cams and pulleys and stuff that would move the doors. I'm simply moving the surfaces so that I can pose them, basically. All right, with that said, let's start with the propellers. I've got the propellers set up so that the angle of rotation and scale have been applied, and the angle of rotation is set so that they rotate along the y-axis. You can see that I've locked the z and x-axis, so if I hit the R key, the only way they spin is in the proper rotation. Right, and these props spin in a counterclockwise motion. And if we look over here, you can see that that means that translates to a negative y rotation. Up here in the timeline, if we go back to 1, we want to set the keyframe here on the rotation. So I hover over this, hit I to set that. I'm going to hit I to set that. Now we're going to move forward some keyframes. 30 works just fine. These are just numbers that I found work well. The idea here is to get enough spinning motion to get a decent motion blur when you render. And we can try like negative 2000 and hit I again and do the same thing here. And these props spin in the same direction, so both negative rotations. And now if we play, we can see that the props spin, but they stop spinning and they kind of slow up. When they start slowly and then they stop spinning at 30. To fix that, select a propeller and go down to Object Transforms, right click, and choose, why don't I see it? Extrapolation mode, linear extrapolation. And we're going to do the same thing here. Right click, extrapolation mode, linear extrapolation. And what that's going to do is it's going to say start spinning at full speed right away and keep spinning even if you get past that end frame there. So now you can see that the animation just runs and the propellers are spinning away. All right, so that's the props. Let's talk about some control surfaces. We'll start with the easier ones first. Sometimes you're lucky and the axis of rotation on the control surface is an exact X or Y orientation. And that's what we have here with the elevators and the rudder. So all we need to do here is we need to, one, set the origin of the axis, the origin of the rudder to be somewhere along the hinge line, and then limit the rotation to the z-axis. So we can do that here by clicking on that. And if I isolate the rudder for a second, like I said, this is not going to be precise as far as where the exact hinge is, but let's say the hinge is somewhere there. If we Shift S, cursor to selected, go back to object mode, right click, set origin to 3D cursor. I've now put the origin of this object there, and I've locked the z-axis. So now if I hit R, that rotates the rudder just fine. So I can rotate it, and then you can rotate it through here. You can animate it through here. They can rotate it, in the viewport, and if you want to put it back to where it's supposed to go, to its neutral position, you can either type 0 here, or you can a shortcut of Alt R will put it back. We can do the same thing with the elevators. This is a little easier. So you can see I've already got a point there selected. Select a point there. We'll make that the axis of rotation. Set the cursor, set origin to 3D cursor. And this one we're going to limit the rotation along the x-axis. So we get that. And now if I hit R, that rotates properly. So we can rotate it here, you can animate it here if you want, or you can just pose it either way. All right, let's do something a little more complex. We're going to do the flaps next. Now, fortunately on this plane, these are not Fowler flaps, which have a more complex motion. These are simply hinged. So we just need to get them to rotate properly along this hinge line. Unfortunately, the axis, the angle here doesn't match the angle of the hinge. So if I rotate this on the x-axis, you can see that it wobbles, and that's not going to work. We need it to rotate along this axis. What we can do is we can use another piece of geometry to reset this axis in the proper orientation. So I'm going to create a cube. I'm going to scale it up, and I'm going to scale up but not in the x-axis. I'm going to hit Shift X and scale it down. And the idea is we want to make a rectangular prism that's longer than that piece, longer than the piece we're trying to rotate. And the other thing I'm going to do, I'm going to go in here, I'm going to put 2 edge loops here. And this is just for alignment purposes. Select the end, cursor to selected, set orientation to 3D cursor, and then Control A to set the scale and rotation. So now we have a long rectangular piece with the origin at one end and the x-axis running directly down the piece. Now we can use this as a tool to reset the orientation of this piece. So I'm going to duplicate this because we're going to use it a couple times for things. I'm going to go in here, tab mode, I'm going to select this vertex, Shift S, cursor to selected. So now the cursor's here, and because we set the origin here, I can say Shift S, selection to cursor, and it's going to snap my tool directly to the center of the hinge. And I'm going to change my pivot point to pivot around the 3D cursor. And if I go into front view and go into wireframe, I can now rotate this piece along that focus there. And I'm going to rotate it up, and excuse me, I'm going to rotate it up even further. And the reason I put those edge loops through the tool is now I have a nice center line on my piece, and I can see that runs through that vertex. I'm going to go into, I'm looking bottom view now. I'm going to rotate it around some more. Looking at the hinge this way, and I'm going to rotate it until that center line runs through the hinge. Just double check the front, make sure we're still good. Or not, it moves a little bit. Back to bottom view, that looks good. Alright, so now you can see what we have is we have this rod running through the hinges here. And what we can do is if we take the flap first, shift select this tool and hit Control J. Don't worry about the shading, we'll fix that in a second. You can see now that the axis of rotation on the flap has been taken from that tool. And if we hit RXX, the flap now rotates along that hinge line. Alright, so we're going to clean this up. We don't need this tool anymore, so I'm in vertex mode. I hit L, and I can select that whole piece, and hit X. I'm going to delete that. And we're just going to, when we join them, it lost its subdivision surface, and it lost its auto smooth. Alright, we're going to duplicate this, and we're going to do the same thing with this one, but this time we're going to use this end as the origin of this piece, because we still want the x-axis running this direction, and this will become more apparent later when we rig them to operate together. So we want the x-axis of both of these pieces to be the same, and we're going to do the same thing here. I'm going to select point, and we're going to move that to there. We're going to rotate it up to line up. Just using that center line to make sure we're on the center of the hinge. And I realize this is not like engineering precise, but it's good enough for what we're doing. Select that, Control J to join them. I'm going to L to select the tool, get rid of it, and then go back and put the subdivision auto smooth. And now if you rotate this along the x-axis, RXX, it also rotates nicely. The thing is, flaps function simultaneously usually. So I'm going to put the cursor back in the middle. I'm going to add an armature, just one bone. I'm going to set the scale and rotation of it. Control A, rotation and scale, and I'm going to move it down. I'm going to call my bone flaps, and I'm going to turn on the name. This way, when it's outside, we'll know, this bone will control the movement of these flaps, and by showing the label, it makes it a little easier to see what's going on. So now we're going to use a driver to control the rotation of these. We're going to use this bone to control the rotation of these. So I'm going to, I've clicked on the flap, and I'm going to add a driver. Turns it purple. I'm going to do the same thing here, add a driver. Now if we go to drivers, and I'll start with this one. I have this flap selected. Click on Euler rotation. Now I want to select my bone, and I want to choose X rotation. And I want to do the same thing here. Choose my bone, and choose X rotation. So if I move this along the x-axis, oops, the flaps now follow that bone's movement. All right, and you can of course animate that if you want. If you wanted to, you could put in a rotation constraint. Rotation where you can set like a min and max. Like if you didn't want the flaps to extend beyond a certain distance, you could set a max of like 20, and you know, it only allow you to move 20 degrees, but that's up to you. So show everything again. Here's our plane now. Select the flap bone, and we can limit the rotation to the x-axis, so we don't have to always hit RX. Now if we just hit R, the flaps drop down along that hinge line. You can see that they rotate nicely on that hinge. Okay, we're going to do something similar but slightly different with the ailerons. We're going to use the same tool technique that we used before. We're going to use a bone to move them, but it's going to be a little different. The first thing to do is to take this guy, and I'm going to move the origin back to this side. And we're going to select this corner piece. I don't know, this flap might use a piano hinge, which means the angle of rotation is along this bottom piece. So that's where we're going to orient this. I'm going to put the cursor there, and you know what? I'm going to put the orientation here. Sorry about that. And then we'll put the cursor back here. Duplicate this because we'll need it again. And now we're going to selection to cursor, and that'll put our tool right there. But actually what I want, that's because it's subdivided. Okay, so I'm going to turn off subdivision for a second just so we can really see that edge there. All right, go back to 3D cursor, and we're going to do the same trick we did before where we rotate this piece, and I'm going to use this center line to get me roughly where I need to be. I can see this orange line running along the front of the aileron, and we're going to rotate it again this way and do the same thing here. So we got a line parallel to that. All right, and that's going to define our new axis of rotation. So select this first, select this, Control J, And now if we hit RXX, the flap, or the aileron rather, runs on that axis. And now we're done with this piece. We can get rid of it. And we can put subdivision back on. All right. Now we're going to do something kind of different, but kind of the same here. So I'm going to move this over so we can see it. Make this median so we can see. So we're going to do the same. We're going to start the same way. I'm going to put the cursor on the corner. Now, when we did the flaps, we changed which side of the tool the origin was, so that the x-axis was the same, right? The x-axis in both sides of the flaps, the red arrow is pointing to the right. Ailerons work in opposite directions. If one goes up, one goes down. So I'm going to rotate this 180 degrees, R180. Now you can see that the x-axis is pointing that way. And now if I go cursor to selected, oops, sorry, there should have been selection to cursor. Selection to cursor, put that there, go into wireframe. I'm going to rotate this up, get this lined up. The same way. I think that looks about right. No, that's way off, sorry. It's the bottom. All right, that makes sense. All right, good enough for this. All right, now we're going to do the same thing. Select that first, select that. Control J to join them. Now if we hit RXX, the flap rotates along that axis. Go into edit mode, L to select the tool, and get rid of it. Okay, we're going to create another bone. So go to armature, single bone. I'm going to drag this one down. Actually, we'll try this one up. And we're going to rotate it up. Set rotation and scale. Right. And this one will work, the ailerons. We're going to use, we want this to rotate on the x-axis, so we want to create a driver. And we also want to create a driver on that one. And we're going to do the same steps here, where we pick the bone. Now this time it's going to be, we want to rotate the bone on the y-axis, left to right. So I'm going to select the aileron, and it's going to be rotation y is going to be the driving force. And then for this one we're going to do the same thing. Euler rotation, choose the bone, stop it, choose the bone, and y rotation. All right, so what happens when we move this on the y, the flaps move in opposite directions. And the reason they move in opposite directions is because when we use that tool on this side, we rotate it around 180 degrees so that the x-axis of the tool was facing the opposite direction as it was here. So now that this driver is basically inverted when it pushes one and pushes the other. So now our flaps work. Or our ailerons work, rather. All right. I didn't mention this before, but I also, all of my aircraft have a center empty that everything is parented to, so that when I roll the aircraft or move it into other positions, all I have to do is grab this and everything follows it. We can also parent these bones to that. So that they follow with us. And now if I move the airplane, I guess we need to reattach the flaps. These guys all get parented to that too. So now if we were to maybe roll across the y-axis, everything works together. You can see that the ailerons actually deflect as the aircraft rolls. So that's kind of cool. All right. See what else we can do. We can do, let's do the Bombay doors, which would basically be the same as the landing gear doors. And this is just another technique. It's a little different. We're going to use a parented circle to get the doors to open up. So let me isolate these for a second. And from the front, I want to create a circle. And it doesn't need to be 32. Make it 12. And I'm going to move it just here temporarily. And I'm going to choose one of the doors, and I'm going to pick like 2 points on it along this edge, roughly trying to find the center of the door. I'm going to say Shift S, selection to cursor, and that puts this control piece on the center of the door. I'm going to duplicate this, move it over here. I'm going to do the same thing on this side. I'm going to choose 2 points along the surface. Ideally, they'd be the same points left and right. Cursor to selected, selection to cursor. Now we're going to top view, and like the ailerons, we want the influence of the driver to be reversed on these two doors because we want them to rotate in opposite directions effectively. We're going to do R180 so that this x-axis is pointing out and this x-axis is pointing out. So these two pieces are basically oriented in opposite directions. And now we can parent the doors to these pieces. Control P, keep object transform, Control P, object transform. And we only want this to rotate on the z-axis, so we can lock that if we want. Sorry, we want only axis on the y-axis. There we go. All right. You can see how this circle now controls that door. So we can create another bone. I'm going to call this one Bombay doors. And we're going to create a driver for these circles, which then in turn will control the rotation of the doors. So add a driver, add a driver. Oops, sorry about that. Wrong button. Add a driver. Select this guy, check the rotation. We want to use this bone this time for the driving force, and we want this Y. You could use any one you want. Let's go X. We'll say X. So X rotation of the bone. Should have applied rotation and scale first, and then we're going to do the same thing here. So drivers, choose the bone, and it's X rotation. And now hopefully, if we move along the x-axis now, you can see the doors opening. Right, so what's happening here is this bone is rotating these two circles, and then these doors are parented to those circles so that as those circles move, the doors open. And because we rotated the axis of this door, of this circle, to be, the Z pointing this way, and on this one the Z pointing this way, when we rotate this bone, these two circles then rotate in opposite directions, and the doors open. I guess it would make more sense to make it rotate along the Y, but either way it works fine. You can open the doors either way, and then of course you could animate this to have the doors open at some point during your video. Doors on the for the landing gear would be exactly the same thing, and then the landing gear themselves, you can do exactly the same kind of thing we did with the rudder, where you set the origin to wherever the axis is, lock so that it only rotates in one axis, and then you can you can animate that movement as well, or you can scroll through here to lower the doors. All right, well, I think that probably shows a variety of techniques you can use to rig the various parts of your model. I hope that was helpful, and thank you for watching.